Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at factorial notation. Now this is really where the A-level stuff starts to get introduced. Factorial notation is just another way of notating basically multiplication. I was going to tell you how we actually notate it, but we'll get onto that in a minute. It's just a way of simplifying a big long list of multiplication, okay? So what we're going to do before we even introduce the notation is to consider 5 times 4 times 3 times 2 times 1, okay? That is just 5 numbers being multiplied together. Notice though that we're starting off with 5, then the next number that we're multiplying is 1 minus the number before it. And then we've got 3, which is 1 minus the 4, multiplied with the 2, which is 1 minus the 3, and all the way down to 1. Okay, so we've got 5 times 4 times 3 times 2 times 1. That is the multiplication of all the numbers, including and below 5, all the way down to 1. Okay, 5 all the way to 1. And we're multiplying all those together. We can write that multiplication using factorial notation. Now, on the screen, we've got 3 examples here, and we can see we're using the exclamation mark. So, what we're going to do is write that as 5 factorial. Now, without knowing what factorial is, you would read that as just 5 exclamation mark. It's actually not an exclamation mark in maths, it's the factorial notation, okay? So 5 factorial just means 5 times 4 times 3 times 2 all the way down to 1. Of course we don't need that 1 there because it doesn't change anything. Multiplying by 1 just, doesn't help, or it doesn't change. But we for some reason just always include that 1. So it's 5 all the way down to 1, okay, if it's 5 factorial. Now, here's just 3 quick examples. If we're not dealing with 5 factorial, let's say we're dealing with 1 factorial, what we want to do is multiply from the number that we're doing the factorial of, including that number, multiply all the way down to 1. So, 1 factorial, we can't get any less than 1, so including 1 and finishing at 1, that just means it is just 1, okay? 13 factorial, again what we want to do is the number that we are doing the factorial of, so 13 all the way down to 1, multiply all of the integers between that number all the way down to 1. So think about that one. 5 factorial was 5 times 4 times 3 times 2 times 1, so 13 factorial is just going to be this. 13 times 12 times 11, and I've put ... in the middle there. That basically means if we follow the pattern, we're decreasing by 1, so all the numbers in between there are included as well, and then 3 times 2 times 1. Okay? So pretty straightforward notation. It can look a bit confusing because you can think, what is the exclamation mark? But it's a factorial symbol. 10 factorial then is just exactly the same. It is just 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, we don't really need the 1, but we just always include it. Okay, so that is what factorial means. Quite simple. Now, I've given you some examples there, but one factorial that doesn't break the rules, it kind of doesn't fit into multiplying down all the way until you get to 1, is 0 factorial. Now there's a little proof, if you like, that you can do that basically shows you what 0 factorial is. You might already know this, you might not, but let's have a look. So I've got here 1 factorial, 2 factorial, 3 factorial and 4 factorial, and I've got what those are equal to. Okay, 4 factorial is just 4 times 3 times 2 times 1. Work out what that is. 4 times 3 is 12, times 2 is 24. So that's what 4 factorial is. 3 factorial is just 3 times 2 times 1. 2 factorial is 2 times 1. 1 factorial, we just discussed, is 1. Okay? So that's what we've got going on there. How from all of those 4 examples can we get what 0 factorial is? 0 factorial doesn't, like I said, fit into the rule of multiplying down until you get to 1, because 0 is actually less than 1. So what we can do is we can actually follow these arrows each time, and we can look at the pattern of the factorials as we decrease the factorial that the number that we're taking the factorial of. Okay, so 24, how can we go from basically 4 factorial to 3 factorial? How can we go from 24 to 6? What can we divide by? Well, if we think about it, we can divide, and I'm going to do it in red. If we think what we can divide by 4, okay? 24 divided by 4 is 6. So if we divide by 4 there, we will get 6. So that's what we can divide by to go from 4 factorial to 3 factorial. Then if we think about how can we go from 6 to 2, that's quite easy. We can just divide by 3. Okay, so again, I'll do it in red. We can just divide by 3. Okay? How can we go from 2 factorial to 1 factorial? In other words, how can we go from 2 to 1? What can we divide by? We can just divide by 2. Okay? And then, well, we don't know what 0 factorial is, but we can work it out by looking at these numbers here. This is what we divide by each time. To go from 4 factorial to 3 factorial, we divide by 4. To go from 3 factorial to 2 factorial, we divide by 3. 2 factorial to 1 factorial, we divide by 2. So really what's happening, each time we are dividing by the number that is 1 less than what we divided by previously. Here we divided by 4, so then we're going to divide by 3, divide by 2. So to go from 1 factorial to 0 factorial, we're just going to divide by 1. So let's do that. Divide by 1. So we're going to do 1 factorial, which is 1, divided by 1 gives me 0 factorial is 1. So it doesn't really fit the pattern, but that's what I want you to take away from that little proof of dividing by 1 less each time. So we can then say, therefore, 0 factorial is equal to 1. And that's a result that I would try and just remember. 0 factorial is 1. Okay? So, pretty nice, pretty straightforward. Let's have a look then at what we can do with factorials. It's all well and good knowing that you just multiply each time, but what can you do with that? So, I'm going to introduce combinations here. At the top of the page, it says we can use factorials and combinations to help us expand binomial expressions. And combinations comes in a little bit in probability as well, but it comes in this chapter here. Combinations is a way of simply working out, and it says here, the number of ways of choosing a certain number of items from a group with a certain number of items in the group, okay? So for example here, it says how many ways are there to choose 2 cards out of a hand of 7. If I have 7 cards in my hand, how can I easily just choose 2 of them? And how many ways can I do that? Okay, so that's how we can use combinations. Now, what is a combination? And this is how we work it out. This is kind of the notation for combinations here. We use this N and R for the N is the number of items in the group and R is the number of items that you're choosing, and we use a capital C. The capital C stands for combination, and if you look on calculators, they actually have that. On my calculator, it's the division sign. If you press shift and divide, NCR is the symbol. And we say that N choose R. That's what we do, okay? That's how we work out the number of ways of choosing R items from a group of N items. Now, how do we do that in terms of factorials? This is what we do. If we have N items, we work out N factorial. And we put that on top of a fraction. Oh, you can also write it like this as well, actually, that I missed out. It looks a little bit like a vector, and on the top is the number of items in your group, and on the bottom is the number of items that you're trying to pick. Okay, so for this example we'll look at in a minute, we're trying to pick 2 cards out of a hand of 7. Okay, so 7 would go on the top there, and 2 would go on the bottom, because we're trying to choose 2 cards from the 7. And how many ways can we do that? So we can write it either way like that, and what we do is we take N factorial on the top of our fraction. Remember, N is, as it says here, the number of, N is the number of items in the group. So the total number of items in the group is N. Work out N factorial and divide that by R factorial. Remember, R is the items that you're trying to select. How many ways can you do that? Here, in this example, I'm selecting 2, okay? And then what you do is you take the difference, you do N minus R, and then you take the factorial. So that is the formula in terms of factorials for when you're doing combinations. Combinations is kind of in the title. How many ways can I do something? How many combinations are there of ways of taking 2 cards out of a total of 7 cards? Okay, this is the example. So that's how we do combinations. It's n factorial over r factorial, and then multiply that by n minus r factorial. Hopefully that makes some sense. I would just remember that formula and apply it each time. Have a look on the internet elsewhere if you want to have a look at the proof of that formula and kind of see where that comes from. But for the minute, we'll just take that as the formula for combinations. If you put it into your calculator as just that, okay, with n and r as whatever the question is asking you, it will just come up straight away. But you could also do that and it would give you the exact same answer. Okay, because really this is what your calculator is doing in the background when you type that in. So, let me just have a quick explanation of this example. It says, how many ways are there to choose 2 cards out of a hand of 7? Here are my 7 cards. We've got lots of different colours on them, and we could basically work through this. But combinations helps us speed up the process. So if I was just to start working through this, I could say this, okay? And I'm going to do it in a different colour. Let me do it in a green. So I could say I'm going to take those 2 cards. I could then say that's one way. Then I could say there's another way of taking those 2 cards. And then another way is taking those 2 cards. There's straight off 3 ways of taking 2 cards. Okay? Let's do a different colour. Let's do a dark blue. I could then say, well, let's take those 2 cards again. So we're not going to count that because we've already counted it on the other one. And in fact, I'll get rid of that. Let's say we take those 2 cards, but then we take the next 2 cards. What about if we take those 2 cards and those 2 cards and then those 2 cards? You can see that it's going to get quite repetitive, and you could maybe double count some certain things, and you're going to be here for a long time. How can we speed this process up? We can speed it up with combinations, and all we have to do is just plug it into this formula here. So I've got my 7 cards. I'm just going to rub out my highlighter stuff there, okay? I've got my 7 cards and I want to take 2 cards, and how many ways can I do that? Let's do the combination. It's going to be n will be 7 and r will be 2, because n is the number of items in the group and that number of items is 7, and then we're wanting to take 2 cards. They're the number of items or number of ways of choosing r items. So we have 2 items that we're trying to take out. So that's going to be 7, and in fact I'm going to write that a little bit smaller. 7 choose 2, which we could write with our brackets, which is going to be 7 choose 2 like that, okay, and it's set the same way. And then that's where our factorials come in, okay. We're going to take n factorial, which is 7 factorial, the number on the top there. We're going to divide it by r factorial, which is the number on the bottom, which is the 2 factorial, and then the difference, multiply that by the difference, and then do the factorial on that. So 7 factorial, we can work that out, is 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is just 2 times 1, and then in the bracket we've got 5 factorial, which is 5 times 4 times 3 times 2 times 1. And then we can be a little bit sneaky here and kind of do some cancelling on the top and the bottom. We can see here we have got 5 times 4 times 3 times 2 times 1, and we've got that exact thing on the bottom there as well. So we can just cancel that out, okay? And if we cancel like that, that's pretty simple. Then what we have is we can get rid of the 1 on the bottom, and we've just got 7 times 6 on the top, and then the 2 on the bottom, get rid of the 1. And then to make it easy, I suppose we can cancel the 6 and the 2 to give me 7 times 3, which is, of course, 21. So, what does that mean? 7 choose 2 is 21. And that is how many ways we can choose 2 cards out of a group of 7. If I had 7 cards in my hand, I can do 2 cards. I can do 21 ways of doing that, if that makes sense. Okay, I can take 2 cards 21 different ways. I could have this grey card with the red, I could have this yellow card with the green, I could have the red with the blue, I could have the red with the purple, etc. There's 21 ways of doing that. Now, as you get the numbers bigger, the numbers increase massively. So for example, if I was to say how many ways can we take 2 cards out of a pack of 52, that would be 52 choose 2. And then that is 1,326. So there is 1,326 ways of taking 2 cards from a pack of 52, which of course is quite large, just thinking that there's 52 cards. Okay, so really that is what combinations is, and factorials are really, really useful if you've not got a calculator to do your combinations. You can just plug it into this factorial formula. So hopefully that makes some sense. Right. We're just going to now have a quick look at Pascal's Triangle. I introduced this in the previous video, and the way I introduced it was to do the addition of the 2 entries above the entry below. So for example, we said to find this 10, what we do is we add the 2 entries directly above it together. So 6 plus 4 gives me the 10 below. Again, this 4 here is found by doing the 1 plus the 3. Okay, but actually we can use combinations to help us work out the entry and what row that is in Pascal's Triangle. Okay, so what I'm going to do is I'm going to consider, and you can do it 2 ways. In the last video I mentioned sometimes that this row here, this first row there, is considered row 0. I'm going to consider it as row 1 because I think that's easier in terms of combinations. So I'm going to write this at the side actually. We'll call this row 1, that is row 2, and then of course it just continues like that, and then this in that method is row 6. Okay? If we consider it like that, we can use combinations to help us work out the entries in the triangle. So I'm going to work out 3 entries, and we'll start off with this 2 here. To work out that entry, we're first going to work out what row it's on and what entry it is along the row. So let's have a look. We are starting with row 1. It's not on row 1, it is actually on row 3. We've gone row 1, row 2, row 3. And it's the second one along in row 3. So it's in row 3 and it's the second entry. Let's write that here. Row 3, second entry. Now, with combinations, all we do, in fact I'm going to write that as a number so it stands out, second entry. With combinations what we do is we just take one from both of those numbers and then we do the combination. So what we do for row 3 is we say, okay, we're going to do 2, choose, and then it's the second entry, so we're going to take off 1 from that. 2, choose 1. Then we can just compute what that is, so we could write that 2 choose 1 like that, and of course that's just 2 factorial, the number on the top, divided by the number on the bottom, which is 1 factorial, and then the difference of those, which is 1 factorial. That's 2 times 1 divided by 1, which of course is 2. And we knew that because that is what we were dealing with there, okay? So that's worked. All we have to do is work out which row it is on and work out the entry of it, and then take one from the row and the entry when we do the combination. It was on row 3 here, so we looked at 2, choose 1, because it was on the second entry in on the 3rd row, so we take off 1 from the entry. And that gives us the number 2, which is what we wanted. Okay? Look at this 10 here, we can see it's on row 6, and it's the 3rd entry along. So I'm going to take 1 from all of those. It's on row 6, so I'm going to take 1 to give me 5. 5, choose, and it's the 3rd entry along, so I'm going to take 1 off that. 5, choose 2, which is 5, choose 2 like that, which is 5 factorial divided by 2 factorial times 3 factorial, because we do the difference, okay? And of course we know that that's going to give us 10 because that's what we've got there. We already know that, okay? All right, let's have a look at the red one then. What's the red one going to be? Well, it's in the 1, 2, 3, 4. It's in the 5th row, and it is 1, 2, 3. It's in the 4th entry. So that one is going to be, let me write it with the C first. It's going to be 4, choose 3, because we're going to subtract 1 from the row and we're going to subtract 1 from the entry we're trying to work out. Now that is 4 factorial divided by 3 factorial times, and I'm just going to go straight for it, 1 factorial. Of course, that is then going to give us 4 because we already know the entry. Okay, but what this allows us to do is work out lots of entries all the way down Pascal's triangle in like row 20, for example. If we wanted to work out, let's say, the entry in row, let's do row 10, 3rd entry. Okay, then all we'd have to do is we'd have to do 9, choose 2. That's 9 factorial divided by 2 factorial times 7 factorial. Okay, and then whatever that is, well, you could put that in your calculator if you wanted to. 9 choose 2 is 36. So that would give us 36 there. So 36 is the entry in Pascal's triangle that is the 3rd entry in row 10. Okay, that's how we can work out Pascal's triangle there. Okay. So yeah, I've summarised it here basically. If you're trying to work out the rth entry in the nth row of Pascal's triangle, you just subtract 1 from the numbers you're using in your combination and do it like that. Okay, now if you look here, I've got n minus r here because you've got n minus 1 minus r minus 1. So the minus 1's cancel just to give you n minus r. Okay, so I think that is right. Yes, it is. Okay, right, let's have a look at some examples. So we've got 2 quite easy examples here, and then 1 that we are basically trying to work out like we just did in Pascal's triangle. So I would pause this and have a go, and then press play when you're ready for the answer. Right. A is quite simple. We already had a look at that at the start of this video. I would always show what factorial means. So 5 times 4 times 3 times 2 times 1. Work out what that is. 5 times 4 is 20, times 3 is 60, times 2 is 120. So that is what 5 factorial is. Hopefully you all got that one. This one is a little simple if you just put it in your calculator. You could just do that, but you could also use factorials, and I think it's better to get into the habit of using factorials so you know what actually this C function, if you like, is doing. 5 choose 2 is doing the factorial notation. So of course that could be written like that, a little bit like a vector. It's not a vector, it still reads 5 choose 2. And then we have the top number, which is 5 divided by the bottom number 2 times the difference, so 3. Okay, and we're doing the factorial of all of those. So work it out, 5 times 4 times 3 times 2 times 1, divided by 2 factorial, which is 2 times 1, times 3 factorial, which is 3 times 2 times 1. Now you could simplify the top here to 120, but notice that we can cancel the 3 and the 2 and the 1 on top and bottom. They can just disappear. And then we've got 5 times 4 divided by 2, of course, which is 10. And remember what this says, 5 choose 2 is the 3rd entry in the 6th row of Pascal's triangle. Let's have a look at that. The 6th row is this row here, and the 3rd entry is 10, which is just what we calculated there. Okay, so hopefully that makes some sense. Now, part C, we just have to do a combination. So, let's do that. The 6th entry in the 10th row, we're going to subtract from 1 from 6 and 10. So we've got the 6th entry in the 10th row, so it's going to be 9 choose 5, because we always are basically choosing the 6th entry, from the 10th row, so 9 choose 5, we subtract 1 from each, so that's going to be 9 choose 5 like that. You don't always have to write this in here, it's just a little simple for you to do that so you get used to the different notation. And then all we're going to do is just do our factorial. So 9 factorial divided by 5 factorial times 9 minus 5 factorial. And of course that's 9 factorial divided by 5 factorial times 4 factorial. And this time I'm going to put it in my calculator just for ease. So 9 factorial, like that, divided by 5 factorial times 4 factorial is just put into your calculator. It's too dark for you to see like that. And then you can just put it in and it gives you the answer straight away, which is 126. So hopefully that makes some sense. I think I've done my best at explaining that there. Really, when you're working out the entry and the row, you just subtract one and then you do the row, choose the entry. Basically, how many ways can I choose 10 from 6 things? Row 10 of the 6th entry. Okay, that's what combinations is. Okay, a little proof with combinations here. All I've told you is the definition of combinations. So all you really have to do is just use that definition and see what you can do with n choose 2. So n is any number here. It's the number of items in your group, if you like. And we're doing n choose 2. So how can I show that n choose 2 is n times n minus 1 divided by 2? Little hint, like I said, the only way you can show that is to use the definition and do some manipulation on that. So press pause and have a go, and then when you're ready for the answer, press play. Okay, let's work through the answer. So what I'm going to do is I'm going to write down the definition, and I'm going to do that in red. I know that n choose r, and I'm just going to write that a little bit better actually, we'll write it up here. N choose r is equal to n factorial divided by r factorial times n minus r factorial. Okay. Now I don't know what n is in this question, but I do know what 2 is. So I can basically replace the r with a 2. Okay, so starting my proof here, on the left hand side I have this. I have n choose 2. And I basically want to get what that is on the right hand side. So let's plug into the definition. I have n factorial divided by r factorial, which I know is 2. So that's 2 factorial, multiplied by n minus 2 factorial. Then I can do some manipulation on that. In fact, I'm going to work down the page just to make this nice and neat. N factorial divided by 2 factorial, which we can actually get rid of that factorial because it's just 2 times 1. And then n minus 2 factorial. I can't really do anything with that just yet. Okay? Right, what I'm going to do is I'm going to actually get rid of the factorials on the n and the n minus 2. And the reason I'm going to do that is so I can see what multiplication is actually going on. N factorial, we start with n and we just multiply all the way until we get to 1. Okay, so let's just symbolise that. N factorial is n times n minus 1, because we just subtract 1 to it, n minus 2, n minus 3, etc. So dot 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 all the way to multiplying by 1. Okay, then here what we have is a 2. An n minus 2, we're just going to start with an n minus 2. So multiply n minus 2. And n minus 2 factorial, again we're just going to multiply, decreasing by 1 each time until we get to 1. So multiply by, we started with n minus 2, so minus 1 will give me n minus 3. Then we'll have n minus 4, all the way until we get to multiply 1. Now, what can we see on top and bottom? Just like we could see on top and bottom here, we had a 3 times a 2 times a 1. On the top and bottom here, I can see that this is going to nicely cancel out. N minus 2 times n minus 3 all the way to times 1 is going to cancel out nicely with what's on the bottom there. N minus 2 times n minus 3 all the way to times n minus 1. And what does that leave me with? It leaves me with, on the top, n times n minus 1 from those two terms there. And on the bottom, we just had 2 factorial, but we got rid of the factorial because we don't need it. It's just 2 times 1, so that's just 2. So on the bottom, we've just got a 2. And that is equal to the right-hand side. So therefore, we have finished. I'll just write, therefore, proved. We've finished the proof, okay? We've got what we started with here, n choose 2. We've got that, and we've done our mathematical steps to show that it's equal to what we're trying to show it's equal to. N times n minus 1 divided by 2. So hopefully that makes some sense. Pretty simple proof, but you've got to basically break down the factorial and know the factorial definition so that you could have done this expansion to see what cancels. And in a factorial proof like that, it is more or less the cancelling that lets you get to your answer. Okay, so let's have a look at I think the final example for this video. This is a little bit different, and actually it's quite easy, so I would pause and have a go. It says, given that 50 choose 13, and remember this could have been written as 50 choose 13 with the C notation, but it's not. It's been written in the brackets, so 50 choose 13 in the factorial definition is equal to 50 factorial divided by 13 factorial times a factorial. We're just being asked to write down, and in fact I've already got the answer on the screen. I didn't rub that out when I went through the examples, so maybe don't go through this one because it's already on the screen. Write down the value of a. It's pretty straightforward because we know what the definition is. We take the top number, we do the factorial, we take the bottom number, we do the factorial, and here we then just work out the difference, and that will give us our a. Because remember, and I'll grab it from up here, this is the definition. We want to work out the difference when we multiply on the bottom, okay? This is the difference of those two numbers there, and we take the factorial. And we can see we're taking the factorial of a there, and so a must be equal to the difference, 50 minus 13, which is of course 37. So that is our final answer.